We can start. Hi, I'm Marko. I have been working on problem 8 fair coin. Problem 8 fair coin reads, in many cases, disputes are resolved with coin toss. It's presumed that this procedure gives equal chance of winning to both sides. Investigate how the chances depend on the tossing mechanism and the coin properties. The task is to prove that the falling coin has the equal chance of falling to each side and check which parameters affect it. The problem fair coin is based on Bernoulli's distribution. Bernoulli's type of distribution is used in modeling random features that can exactly have two values. For one, values can be 0 or 1. For 1 we say that it's success, and for 0 it's failure. We can see here, we say for B is probability of getting success, or 1. I've been using a statistical test, C squared. This way is more objective than my personal estimation, because there are two options, tail or head. I have 1 degree of freedom. For 5% of deviation, I have 3.841 degrees of freedom. That means if my say squared is smaller, then 3.845 deviation is within normal limits. I've set up 5 hypotheses. Hypothesis number 1 is tossing height is not important when tossing coins. 2, by increasing the number of throws, the deviation will decrease. 3, when we toss a coin in vertical position in regard to the floor, we will get results closer to 50-50 than when we throw the coins in parallel position. 4, if coin has a bulb on one side, it will more often turn out to be other side. And if we toss a symmetrical coin, the deviation will be smaller. Hypothesis number 5, we will get the most accurate result with coins middle size and next. To check my hypothesis number 1, I've I threw coins from 3 heights, 0.25 meters, half meter and 1 meter. Flat piece of wood, I've marked 3 heights and threw coins with it. I threw a 10 lipa coin. It's quite symmetrical, and that's one of the reasons why I have been using that coin. I threw the coin parallel to the floor with the tail facing up. From the graph and statistical tests, we can see that the deviation does not depend on the height from which we toss the coin. That means that my hypothesis number 1 is correct, but it's advisable to throw coins from a higher height. If we look at the deviation graphs for every 100 throws, we can notice that all 3 graphs confirms my hypothesis number 2, that the deviation decreases with increasing number of throws. I was interested to see if there's any difference with a coin which has a hole in the middle. I threw a coin with a hole 1,000 times from height of 0.5 meters. I was losing a 5 crown Norwegian coin. I threw the coin parallel to the floor with the tail facing up. We can notice that deviation is within normal limits, and the statistical test confirms that there is no difference. To check my third hypothesis, I threw a coin in 2 ways, vertical in regard to the floor and parallel. I threw 10 lipa coin 1,000 times for each way. I was throwing the coin from the height of 0.5 meters. And I threw 10 lipa coin. First way, I threw a coin parallel to the floor, but this time with the head facing up. And we can notice that I had more head than tail. So if you threw coins parallel to the floor, side which is facing up is more probable to appear than side which is facing down. For vertical throwing, it was clear from the very beginning that the deviation was very small. which means this way of throwing is better. That means that my hypothesis number 2 is correct. To check my fourth hypothesis, I was looking for a coin that has a big bulb on one side, and for a symmetrical coin, I found a $1/4 American dollar which has a quite big bulb, that's a head of George Washington, and 100 Italian liras from 1955 to 1989, which is quite symmetrical. And I threw $1/4 and 100 Italian lira 1,000 times from a height of 0.5 meters. For coin with a bulb, we can see that the coin fell with the tail facing up more often because the head is heavier. That partly confirms my hypothesis number 4. We can see that psi squared is bigger than 3.841, so deviation is bigger. For symmetrical coin, when we are throwing a symmetrical coin, it was clear from the very beginning that deviation was very small. This means that my hypothesis number 4 is correct. To check my fifth hypothesis, I threw a coins of different size and mass. I threw 5 and 1 kuna coins and 10 lipa coin from 0.5 meter height. I threw the coin vertical to the floor. We can notice that deviation is within normal limits for each coin. This means that my hypothesis number 5 is correct. We can see from statistical tests that deviations are within normal limits. We can conclude that choosing height is not important when choosing coins. By increasing the number of throws, the deviation will decrease. The better way of throwing coins is vertical to the floor than a parallel to the floor. If the coin has a bulb on one side, the results won't be accurate as with a symmetrical coin. If we throw a bigger coins, we should increase height, and there is no difference with a coin in a whole. Just one thing is important to coin that it's symmetrical. Thanks for attention.
Okay, next phase is clarifying questions by the opponent.
Do I have to write it down or just ask him now?
Just ask him.
What do you think would happen if you threw your first coins with the head up?
I've thrown 10 lipa coin with the head facing up, so I have more times head than tail. Here I have thrown 10 lipa coin with the tail facing up, and you can see that the tail was more often than a head.
Do you think that the coin is actually fair?
It depends on the shape of coin. If you have a coin that has a bulb on one side, it won't be so accurate. One side is have more probability to appear, and a symmetrical coin is fair.
And what would happen if we threw a coin like this? Not facing the tail or head, just the side. What would happen?
Vertical, you mean? I've thrown coins vertical.
Oh, okay.
Yeah.
Okay.
Yes. Here is more tail because often a head of coin is heavier than the head bottom is bulb.
Okay, you have now preparation time.
Clarifying questions, we didn't have enough time to write them down. The solution was we thought that there was enough repetitions and parameters, points of description. why is it advisable to throw a coin from greater height?
Because then a hard coin have enough time to flip or bounce to the surface. If you throw a coin from a small height, coin won't flip and results won't be accurate as with higher heights.
Do you think the number of flips can affect the results?
No, because I throw coins free fall, so I grab a coin and then just.
What would happen if a coin was made from a different material, let's say wood or something like that?
I have that's not matter because I have the coin mass and the mass of coin doesn't affect the result.
Conclusion, the problem was very well solved and that's it.
So this was discussion and okay. So reviewer, you have time for clarifying questions.
Okay. First is for reporter. How did you throw the coin?
Free fall.
Okay, with hand.
Yes.
Okay. And why did you choose those tests for calculation? I mean, why didn't you, for example, calculate the average number of getting tail?
But there is a lot of statistical tests, and I thought that this is the best one for this kind of problem.
Okay. Why didn't you use like average or
Average
like that?
in this case, average is like a percent, and I was using say square test because I have expected frequency and frequency which I've got, and
Okay. Do you have any idea how you can improve your measurements, more specifically showing the...
yes, I would definitely automate process.
No,
Process.
do you have an idea how?
Well, yes, I would make some construction which would throw coins.
Okay, and I have a question for the bone. What do you think why material is better?
I thought because of weight and sensation. Maybe if it was
Okay, can you explain how it would affect? What do you think?
I'm not sure. I just thought that maybe if the coin had more weight, that it would flip a few times faster or something, 2 times more, and maybe affect the result.
I proved that mass and the size of the coin doesn't affect the results.
Why?
I proved that because
Can you explain why? Like that.
because just one thing is important, that the coin is symmetrical. The coin is symmetrical because you can throw a coin of 5 centimeters radius and from, I don't know, 1 centimeter, and it won't be important.
Okay.
So you have the 2 minutes for preparation, is that correct? Okay, so time's up.
Okay. reporter had a lot of measurements and he tested the right parameters and he had a good choice of statistical test, but he didn't have an explanation why he used those ones. And I would like if there was some explanation of coin falling or some forces which affects on throwing. And I didn't see measured mass or volume of coin. Maybe that's my fault. And for opponent, she didn't use her time and she didn't have the discussion. So I think that opponent could be better, and I think that this problem is solved quite good. That's it.
Okay,
First, I'd like to say that the presentation was not very clear because you were talking too fast, so it was hard to me to understand everything. Then the first hypothesis you had that let me go back. So that tossing height is not important for the result, but what if we toss a coin from the height of 1 millimeter or 2 millimeters? Would that affect the result?
Yes, there are some limit heights when tossing when coin won't flip, and the result won't be so accurate.
But did you investigate those low heights? I mean, it's clear that the chances are the same for a head or tail if we throw a coin from 1 meter, but if we throw it from 2 centimeters or at low heights.
I think that then results won't be as accurate as with in 1/2 meter and 1 meter tossing, but I haven't done that.
What do you mean by accurate?
Accurate, like
You won't get the same probability.
50, accurate to get closer to 50-50%.
But you want to investigate, is the height influencing the probability of if you're getting the head or tail?
Yeah.
You don't want to find the height from which you will get 50-50, or maybe.
Yes, but I say for chance to fall every side. If we decrease high to like 1/2 centimeter, the chance won't be the same. If the coin is parallel to the floor, like it would fall to that side, which is facing up. It won't turn.
I just wanted to say that maybe you should have investigated those low heights. Maybe there is some connection between the height and the result of the coin tossing. The second question, what if the hole is not in the middle of the coin, but it's...
Yes, then a coin won't be symmetrical, and I think that chances won't be 50%.
Why do you think so?
Because the coin isn't symmetrical.
But looking the head and tail is the same, right? You have the same asymmetry, so to say.
I should investigate it, but I think the result won't be as accurate as...
You mean you won't get 50-50 chances? Okay, do you have idea how would you make an unfair coin?
Just to put something to one side to make it heavier on one side.
Why?
Because I have proved that a coin with a bulb, which is not symmetrical, it's heavier on one side. Chances for tail and head aren't the same.
Okay, and when you experimented with this, that was American coin, or
Yes, quarter dollar.
did you have more of these coins, or did you just have this one?
One.
I mean, the different quarters of the dollar.
No.
Maybe that coin had some
Regularity.
irregularity. Yes.
Yes, but I had more coins of quarter American dollars, and they are the same.
I mean, but inside. Okay. That's all from me.
Okay, first I would like to ask you if you can draw us a coin and a force in it.
Force. Force.
That's gravity. Okay. So,
Coin. There is a coin and there is a force.
okay, let's just, if you can vertically draw it, and just the line, the two lines that, so, and the force on down, okay. And now when you have a bulge, where is the force?
If bulge is here,
Okay.
force is like here.
So the earth moves.
No. Force is still
Direction of the force is here, okay.
down, but
Is this force causing some torque on that coin?
can you repeat the question?
Is it causes some rotation of the coin or something?
Yes,
Why?
because if we you can think that this is one this coin and this like there are two forces.
Are they parallel or you?
Yes, but this force changes the direction of this force, and the coin flips, and the ball gets down.
Okay, I'm not satisfied with the explanation, but we will continue. What if you throw a coin on a low height, but you throw it vertically?
If a coin is symmetrical, results the chance would be 50-50, and if it has a ball,
What does influence that chance?
I think that the ball influences that chance.
And also method of tossing coin.
Yes.
Because if you're tossing it with your hand, then you maybe can toss it
Yes.
more on the
Yeah,
other
okay.
one side. Okay, can you, how would you calculate probability of 3 times getting a head of a coin?
3 times in a row.
So if you toss a coin 3 times, what is the probability that head occurred on all 3 times? If you have a probability of head is P, or 0.5.
Probability is 0.5, and then we have 3 times, just
So you just multiply the probabilities of each time. So first time you got head, okay, 0.5. Second time you got head 0.5, and the third time. So you multiply them. So you should know that when you're talking about Bernoulli and everything, what's the probability of that place. You shouldn't be using your background of presentation because it's hard to see text and graphs. You had 10 Lipa coin. What are the properties of that coin that are relevant to you?
I think that that coin is quite symmetrical, and that's one of the reasons why I have been using that coin.
Okay, when you are talking about the kite from which you are tossing it, you should give the diameter of the coin, because it's relevant to know what's the dimension of the coin relevant to the kite. Also, you should give the mass for the coins that you tossed when you said you compare the different coins with different weights, but we don't know the ratio between those coins. So, is the mass difference relevant? Also, you should spend more time on graphs, because we cannot analyze it for you, because you're on the graph 2 seconds and I don't know what's on x-axis, what's on y-axis or similar. You should analyze it for the rest. So, can you open some graph? I think it's open. So what is a series of tossing?
A series of tossing, one series have 100 toes, and that's it. And so there is 100 tossing, 200, 300, 400, and there is a percent of for 100 tossing, which is percent for the head and percent of tail. And the blue line shows 50%.
Okay, I have a question. You say this is a percent and it says on the y-axis it's 0.5%. So it's not a ratio. You should say it's a ratio 0.5 or percent 50%.
50%, but you can...
Here, percent means that you divide by 100 and you write percentages.
I had to
Multiply.
yes.
No, yes, multiply. What did you compare in statistical tests?
Statistical tests.
So here you made some statistical
Yes.
tests. What did you compare?
But there is expected frequency, and there is the frequency that I've got.
Okay.
And that's it.
What are normal limits?
Normal limits, it's, you can, on this slide, you can see normal limits. I said that normal limits is everything that is smaller of 3.841. That's
Okay, you should, when you're presenting that, first when you say it has 3.841 degrees of freedom, I'm not sure what does it mean.
because maybe we have 2 sides and there is 1 degree of freedom, and I found a table on the internet for 5% of deviation. The value was 3.841, and everything that is smaller, if the, say, square is smaller of that, I would say that deviation is normal limits.
Okay. I'm just not sure is the 5% should be used for term degrees of freedom or 3.841, but okay. You should have a picture of your experiment. Or a video on start when you throw a coin, when you toss a coin, just to demonstrate what is the problem. Okay. For the opponent, clarifying questions went to discussion. So there wasn't clear what is statement, what were the clarifying questions, and what was the discussion. The reviewer said that you didn't have discussion, and I almost agree with her because I didn't see what was discussion. That I'm wondering what were the problem while you prepared your position.
Can you repeat the question?
What made you? What were the difficulties you encountered when you prepared that opposition?
Because I'm 8th grade and I'm not familiar with all the math calculations. We never learned how to do that, and
Okay, in that case, you should guide the reporter to explain these things to you. So, okay, can you explain me what's that probability? So everything you don't know, you ask him. For a reviewer, you had a good point. Yeah, you couldn't draw conclusions of discussion, but in other cases you should. And that's all. Walter, do you have questions?
No.
Anna, do you have questions?
So just a few very short comments. As you mentioned, it wasn't clear from the beginning how did you draw your coin. Just when you draw this picture here, I understood. How do you make sure that you always had the same initial position of the coin?
So I try to choose coin every time in the same position. There are some deviations of that positions, and that's my effect. And that's one of the reasons why I would automate the process.
Will you come up with something that is more stable at the beginning, like just always have the same position of the coin because some holder or something like that?
Yes, I could make some construction that will throw coins every time.
And you wouldn't affect it as much as you did this
Yes.
time, and as you already mentioned, it would be good to think of explanation. But just another issue, when you try to find out how this asymmetry affects your results, did you pay attention to the mass of these two coins, to one of the $1 and lira?
No.
Did they have the same mass?
Because they're not, I think they're not the same mass, but I have proved that the mass
You
and
prove that just later, so it's always important. If you don't
Yes.
know about mass, then you have to control, that they
Yes.
are controlling variables.
Right.
So if you want to do it this way, your experiment, then you have to put your hypothesis 5 before 4, and then say, okay, I proved that the mass doesn't affect. Then I can have two different masses, just different asymmetry. That's important. Always to control all other variables, but the one that you want to test. So,
Okay, thank you. We can continue to the next slide.